Just as for the z-test and t-tests, when the test statistic is significant, one computes a measure of effect size. For ANOVA, the simplest and most direct way to measure effect size is to compute eta-squared, which is represented by the symbol shown on the slide. For eta-squared, we don't have a table to consult that tells us whether there is a small, medium, or large effect. Instead, we convert the eta-squared value to a percentage, and that percentage represents the percentage of difference between the treatment means that can be attributed to the treatment effect. At such time as it is appropriate to calculate the eta-squared, one consults the ANOVA table and divides the SS between treatments value listed on the table by the SS total value. As I explained earlier, the ANOVA test allows one to simultaneously compare the variance differences between more than two groups all in one omnibus statistic. However, along with the eta-squared measure of effect size, when one has a significant f-test, the customary additional next step is to calculate post hoc or post tests. Post hoc tests are like doing a series of t-tests. However, if one were to do just a series of t-tests, the risk of type 1 error accumulates and is called the experiment-wise alpha level, because increasing the number of hypothesis tests increases the total probability of a type 1 error. Post hoc tests compare two individual means at a time, pairwise comparison, using special methods to try to control the risk of making a type 1 error. Our text presents and discusses the Tukey post hoc test, which is one type of post hoc test among a large number of such tests available. Finally, listed on the slide are the assumptions that are specific to the ANOVA test. The independent measures ANOVA requires the same three assumptions that were necessary for the independent measures t-test.